Okay, a very short review of the concept of derivatives. Not necessarily questions, but just the idea. What does it mean before we move on? This is a video review, and I'll also show you a photo of the whole thing if you would like to access it that way. Okay, derivatives. When we talk about I better spell it right. What we're talking about slope. It's all about slope. Okay? And slope we know. Slope, so far we've always called slope m, is about the change in y, the rise. We're going to write change in y over the change in x. Okay? And we can easily do that, even if we're talking about a curve. So if I want to find the average slope of that curve between those 2 points, I could connect it with a line like that, and then I could calculate the slope of the change in y between those points and the change in the x. We've done that before. And so that's an average of the slope of that curve. If I would make those points even closer together, it would be more of a true average. So if I would find then the slope of that curve, I could do that. I'd have to move it exactly. And I could find the average slope between those points. But how can I find the slope at one point? Like here, we can take an average between those 2 points and find the average slope of that curved graph. But how can I find the slope at one point? Think about finding the slope at a point for a minute. We would take the difference in y's, which would be a change or a rise of 0, and the change in the x's at that one point, well, that would be a run of 0. Yeah, indeterminate. We know that we can't calculate that. It's 0 over 0. Doesn't work. So that's where, ding, 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 derivatives come in. Derivatives find the slope at a point on a curve of the graph. Basically, a derivative finds the limit of the slope as the change in x, that's the run, right? The denominator, gets closer and closer to 0. So if that would be so close to 0, such a tiny bit that it's just a tiny point, then what's the slope? That's what the derivative finds. And that's why we say with respect to x. So here's the process of how we write it, or why we write it, dy over dx. So the derivative is equal to the change in the y divided by or over as the change in x gets very close to 0. So we're moving towards a point, which equals the derivative of y. The change in y is the derivative of y with respect to the derivative of x as it approaches 0, gets tiny. And that's why we write d of y over d of x. This can also be written like this, the derivative like this. This means the same thing. Usually we find it written the first way, but the following is a link to the mathisfun.com website where they explained it well. So we write dx on the bottom in the denominator instead of the change in x heads towards 0. And the derivative of is commonly written like this. So we say d of dx of whatever we're taking the derivative of. So you can see here, if we're taking the derivative with respect to x of x to the x squared, we know from our lessons in this unit that the derivative is 2x. The derivative of x squared equals 2x, or simply we say dx of x squared equals 2x. What does it mean though? Here's the question that I'd like us to come to understand with this little short video. It means that for the function x squared, you can see here this parabola is x squared. You know how to draw that. the slope, or the rate of change, at any point on this curve is 2x. That's what the derivative means. The rate of change is 2x. So when x equals 2, right here, at that point that they've given, when x equals 2, the slope is 2x, or 4. So the slope then of this tangent line, or we can say the slope of that point, is 4. Or when x equals 5, it's not shown on here, then we could plug in the 5 and say that at that point on the graph, the slope is 10. Now we also have used this way of writing the derivative. So read through this again, and I hope it's provided some clarity of what the meaning of derivative is.